the electrolysis of molten compounds for Cambridge IGCSE Chemistry. I'll start with the key ideas of electrolysis. You may skip these first 4 slides if you are very confident. We'll move on to the electrolysis of molten compounds, then the electrode half equations and the idea of oxidation and reduction, and then I would recommend you try the exam style practice problems. So, considering solid metals which conduct electricity through the flow of delocalized electrons, the electrons in a metal are attracted to a positive electrical terminal and repelled by a negative electrical terminal. The electrons, which are negatively charged of course, flow through the metal in the direction of negative to positive and carry charge. The metal itself undergoes no chemical change. Now consider electrolytes. Electrolytes conduct when molten or in solution, but not as a solid. We explain the electrical conduction properties of electrolytes by saying it is the mobile ions that carry charge. So if we consider an ionic compound, sodium chloride, sodium a metal, chlorine a non-metal, forming sodium and chloride ions, positive sodium ions and negative chloride ions, as a solid, the charged ions are fixed in position in a giant ionic lattice. However, if we heat the ionic compound, the electrolyte, so that it becomes molten, the ions are free to move about. Similarly, we can free the ions to form mobile ions by dissolving in water. So ionic compounds, electrolytes, when molten or dissolved, conduct electricity, but not as a solid. Only in a solution or in the molten liquid are the ions free to move. So let's consider the electrolysis cell setup. The electrolyte is either molten or in solution. Either way, it contains positive and negative ions that are mobile, that are free to move. The electrodes themselves are made of an inert material such as graphite. The negative electrode is referred to as the cathode and attracts positive ions. The positive electrode is referred to as the anode and of course attracts negative ions. Electrons flow in the external circuit from anode to cathode, but across the electrolyte, it's charged ions that flow and carry charge. Over the next couple of slides, we're going to look at the electrolysis of molten compounds, specifically lead bromide, and introduce electrode half equations and the idea of redox chemistry. Considering the electrolysis of molten lead bromide, PbBr2. So here we have molten lead bromide, heated to achieve the melt, graphite electrodes, external circuit, cathode and anode. By heating to melting, the lead and bromide ions become free to move. So if we consider the bromide ions, they are of course attracted to the anode. Opposite charges attract. The lead ions are attracted to the cathode. Opposite charges attract. Bromine vapor forms at the anode. So a brown vapor of bromine forms at the anode, and you are expected to recall that observation. Whereas at the cathode, Metallic lead forms on the surface of the cathode and falls to the bottom of the electrolysis vessel to form a globule of metallic lead. Again, you are expected to recall that observation. So let's consider the changes at each electrode, and these involve the loss and gain of electrons. And we will be writing ionic half equations to describe those changes. Bromide ions are attracted to the positive anode. Opposite charges attract. They lose electrons, changing to bromine molecules. So bromide loses electrons to form bromine molecules. Stop the class. Can you write a half equation? Give it a try. Come back to check. Okay, so two bromides, each loses one electron to form bromine, Br2. Let's consider the cathode. Lead 2+ ions are attracted to the cathode. They gain electrons and change into atomic lead. Having seen this ionic half equation, have a go at writing the change at the cathode. Stop, restart when you're ready. Okay, so lead 2+ ions gain 2 electrons to form atomic lead. The overall reaction is a decomposition of lead bromide. We started with bromide ions and lead ions in the form of lead bromide. We're producing lead metal and bromine. So lead bromide forms lead and bromine, a decomposition. Introducing two new terms, oxidation. Oxidation is defined as the loss of electrons. So here, bromide ions lose electrons. Each bromide loses one electron. This is an oxidation. The opposite is applied to the term reduction. Reduction is the gain of electrons. Here, lead 2+ gains 2 electrons to form lead atoms. We'll be using these definitions to classify certain types of reactions in various parts of the chemistry specification. I would recommend that you try some practice problems before moving on. So here are some exam-style problems. Identify the products at the positive and negative electrodes during the electrolytic decomposition of each named molten electrolyte. So we have molten lead chloride, molten sodium bromide, molten aluminium oxide. What are the products at the negative electrode, the cathode, and the positive electrode, the anode? Stop. Create your answers, come back to check. Okay. At the negative electrode, we would form lead. Lead forms positive ions. It's a metal. At the positive electrode would attract the chloride ions, the negative ions, to form chlorine. Similarly, sodium positive ions would be attracted to the cathode and formed as an element. Bromine would form at the anode. Aluminium and oxygen are the two products. Classify the products at each electrode. Have a quick think. Restart when you're ready. Okay, well, lead, sodium, aluminium are metals. So metals form at the cathode. At the anode, chlorine, bromine, oxygen are all, of course, non-metals. So non-metals form at the anode in the electrolysis of a molten electrolyte. So in this problem, complete ionic half equations for the reactions at both electrodes during the electrolysis of molten sodium bromide. So we've got two half equations to complete. Classify the changes as oxidations or reductions, and complete the overall reaction equation. So in the exam paper, you were provided with partial equation. Stop the class and come back to check your answers when you are ready. Okay, so sodium ions gain electrons to form sodium atoms. We've got half a bromine molecule, so we only need one bromide ion, loses one electron to form half a bromine molecule. Now, the classification, sodium is gaining electrons, that's reduction. Bromide ions are losing electrons, that is oxidation. Simple application of the definitions of reduction and oxidation. Completing the overall reaction equation, where we've got 2 sodiums and 2 bromides on the left, 2 sodiums on the right, so we write the bromines not as 2Br, but as Br2, the bromine molecule. Well done for finishing the class. If you need more practice, use textbook questions and then past paper questions. Keep to that order. If you want more classes, look at the course list and links in the video description. If you found the class helpful, please recommend it to a friend. Subscribe for new classes, online assessment opportunities and exam tips. Please like, and comments are always appreciated. Thank you for watching.